Right. Now that we're dividing decimals by decimals, instead, we have to take an important step at the beginning. The number we're dividing by, called the divisor, which is either in the bottom if it's written like a fraction, or it's the second number listed, that number, the divisor, must be written as a whole number. And as you see in the title, it's a decimal at this point. So we're going to rewrite that number, meaning we're going to rewrite the entire fraction, similar to how we would rewrite a fraction, by multiplying both numbers by a power of 10 to move the decimal based on the divisor. So when we're dividing with decimals, and we're dividing by another decimal number, if that divisor has a decimal, we have to move that decimal based on that number. So the divisor is in control. If we look at this first example, 3 6/10 is our divisor. And you'll notice that there's a decimal in it. There cannot be a decimal in this number. So we're going to multiply all numbers in this problem by the same number, as if it were written like a fraction. This is still a division problem. This fraction bar line just means to divide. Since we cannot have a decimal in that bottom number, we have to multiply it by a power of 10. 3 6/10, if we multiply it by 10, that's going to move it one decimal place, because 3 6/10 times 10 is 36. But we have to keep the relationship between these two numbers the same, which means we also have to multiply that top number by 10, by the same number, just like we would a fraction. But it's based on the denominator, or the divisor. So in that case, we instead have 936 divided by 36. It's still going to give us that same relationship and the same quotient. However, now we don't have the decimal in the divisor. So we can write it as topsy in the boxy divided by 36. Here it'll be helpful to write numbers off to the side. If we check maybe 2, 36 times 2, it's going to give us 12 there and 7. We know that we can't add 30 to it because that'll put it above. So it's going to give us a 2. It didn't work to go into just 9. 2 times 36 is 72. So now when we subtract, we have 21 left over. So we need to bring down the 6. When we bring down the 6, now we have to figure out how many that would be. So with it ending in a 6, what times 6 gives us another 6? We could take a guess that it could possibly be 6. It could be other values as well. Maybe it doesn't work out perfectly. However, we pick a number to check. That gives us 36. This gives us 18, 19, 20, 21. And that happens to be exactly what we need. So we know that 93 6/10 divided by 3 6/10 gives us 26. There are a couple ways that we can check to see if this works. One way is just to estimate to see if it's close, using the quotient that we got and a rounded divisor. If we take 26 and we multiply it by about 4, it should be near our 93 6/10 dividend. That's going to give us 24, and we're at 104. It's a little bit above, but so is our decimal. And we know that we are somewhere close. Another thing that we can do is to multiply it by the exact value. So if we were to take the 26 and multiply it by exactly 3 6/10, we're just doing the reverse operation to complete the fact family. So we should be getting 93 6/10. 6 times 6 gives us 36, carrying that 3. 6 times 2 is 12, plus 3 is 15. We're finished with those, so now we have to hold the place value. 3 times 6 is 18. 3 times 2 is 6, plus 1 more is 7. And then we add them together. At this point, we need to check decimals. So we've got 1 in the problem altogether. So we have 1 digit after our decimal in the answer, which is exactly what we had. Our estimate was close. When we checked, we got it exactly. So we know that 26 is the correct answer. Let's try another example. Keeping in mind, the divisor, the number we divide by, cannot have a decimal. In this case, we need to move it 1 decimal place. So, in order to do that, we need to multiply it by 10. If we multiply the divisor by 10, we also need to multiply the dividend by 10, because that has to match. So when we do that, instead we have 624 divided by 39. Because we multiplied them both by the same number, it works, and now there's no decimal in our divisor, which is exactly what we wanted. So we put 624, the number listed first, in the box, divided by 39. If we were to multiply 39 times 2, it would be too big for that first part, because 39 doesn't go into 6. So in this case, we would have an 8 there because of 18, and we would get 78. It's too large, so we know that it only fits into 62 one time. So then we're going to subtract, and when we do that, we get 23. We can always borrow. Then from there, we have to bring down the 4. Now we're going to think of another one to multiply by. We needed to end in a 4. And I know that 9 times 6 gives us, well, we'll go 9 times 6. We'll give it a try. 39 times 6. That's going to give us 54, excuse me, from before. Carry the 5. That gives us 18. And 23, and that's exactly what we needed. So we know this is a 6. 6 times 39 is 234, and we get 16 for our quotient. We can use an estimate to check. 3 and 9/10 is almost 4. So if we checked 16 times 4, it should be somewhere close to 62 and 4/10. Which it really is, because 64 is really very close to 62 and 4/10. So using an estimate was helpful to check our work. We can also use the exact values to check. So if we did 16 times 3 and 9/10, it should be our exact amount. 9 times 6 is 54. And then 14, done with the 5 and the 9, so we have to hold the place. That gives us 18 and 4 if we add them together. And then check our decimals, 1 in the problem, so 1 in our answer, and that's exactly what we had. So we know 16 is the correct answer. So we're using compatible numbers, which we get sometimes from estimating, or the exact numbers and multiplication to check if our answer is correct. We'll do a couple more examples on the back side. For this first one, you'll notice this time, once again, that our divisor has a decimal, but it cannot have a decimal in the divisor. If we were to multiply by 10, that would only move it 1 place value. So we'd have to multiply by 10 again, and 10 times 10 is 100. So really, we have to multiply by 100 to move that decimal far enough. The divisor is what's deciding how much we multiply by, so we have to multiply this one by 100 as well, which moves it 2 place values, 2 digits over. So now instead we have 151 and 2/10 divided by 54. There can still be a decimal in the dividend like you see. We just cannot have one in the divisor. So now if you write our problem as 151 and 2/10 divided by, so inside the box with 54, we can do our division. We can, even from the beginning, start by putting our decimal straight up. 54 doesn't go into 1. It doesn't go into 15. So if we check 54 times 3, because 50 times 3 is 150, and that's a little bit too much, we multiply it by 2, we get 108. If we would have multiplied by 3, we would have had 162, which is too big. So we know this number has to be a 2, and we'll subtract 108. Borrowing will be necessary, giving us 43. So now we bring down the 2. Now we have to figure out what's going to get us closest to 432 with our 54. 3 was nowhere close. 4 to 32, so maybe 4 times 8 is 32, so we could check that. 54 times 8. 8 times 5 is 40, plus 3 more is 43, which is what we needed. So we know that it's going to be an 8 directly above the 2, and 8 times 54 is 432. So 2 and 8/10 would be our answer. Again, an estimate's very helpful just to check for our decimal. So if we were to estimate 2 and 8/10 is about 3, multiplied by 54 hundredths, which is, you could say half. If we said half, half of 3 is 1.5. Otherwise, if we said 3 times 1, if we rounded that to a whole number, it'd be 3, which again is still just 1 digit to the left of our decimal. So we're just in the ones place. So we know our decimal's in the correct spot, and 2 and 8/10 would be a reasonable answer. One final problem. Starting with our divisor, we can't have the decimal. Because we have to move it 2 places, we have to multiply it by 100. If we move it 2 places in the divisor, that means we also need to move it 2 places in the dividend, which is also multiplying by 100. That has to match. So our new problem, which will give us the same answer, should look like this. We move the decimal the same number of places, so there's no longer a decimal in our divisor. Then from there, we can divide, putting our decimal straight up. 18 doesn't go into 1. It doesn't go into 13 either, but it'd be nice to have a number there. So 18 goes into 13 0 times. So because it didn't work, now we're checking 138. 18 into 138, we may need to check a couple there. If we guess a 5, 18 times 5, that gives us a 40. And then 9, that's 90. We're still quite a ways away. So if we check 18 times 6, that gives us 48 initially. And then 10, which again is quite a ways away. So if we did 18 times 7, that gives us 56. And 7 times 1 is 7, plus 5 more is 12. So that's getting closer. Let's check to make sure that we can't get even closer by doing 18 times 8. That gives us 64. 8 times 1 is 8, plus 6 more is 14, which is too big. So we know that it has to be the 7. 7 times 18 was 126. Now with all this work on the side organized, we have a reference for going forward if we need it. Then when we subtract, we have 12 left over, and we bring down the 6. You'll notice that the 126 is one that we already used when we multiplied by 7. So that gives us our exact answer. And our quotient is 0 and 77 hundredths. We can use multiplication to double check that our answer is correct for the exact value and decimal point. So we have 77 hundredths multiplied by 18 hundredths. 8 times 7 is 56, carrying the 5. Again, it's 56, but we add 5 more, which is 61. Then we have to hold our place value, multiplying by 1 both times, and then adding them together. We have 2 decimals there, 2 here, for a total of 4 in our answer, which matches our dividend that we started with, which means that our answer, the 77/100ths, is the exact correct answer. Keep in mind, when you're dividing decimals by decimals, the divisor, the number we're dividing by, must be a whole number. There cannot be a decimal in the middle of that number. So we have to multiply by a power of 10 to move that decimal to the end. Making sure that we're multiplying both the dividend and the divisor, just like we treat a fraction, so that they still have the same relationship with each other.